lesson Unit 2, lesson 11. So the first question here is asking you to find the constant proportionality. So let's do that because that's not that difficult. Avi walked 15 feet in 3 seconds. So if we would create a table, I think it's easier if you see it in a table. Right? Here is x and y. Here's the seconds. Here's the feet. So this is what they're giving us. 3 feet, 3 seconds, walks 3 feet. So I want the unit rate, right? This number over here. What about if I walk 1 second? What is my unit rate, and therefore what is my constant proportionality? To find constant proportionality, we take k and divide y over x. And the only value that I have that I can do that is 3 and 15. So if I do that, I get 15 divided by 3, and I get that my constant proportionality is 5. So k equals 5. Notice that 3 times 5 is 15, 1 times 5 is 5, and if I put other values over here, 2 times 5, we'll always use that, right? It's 10, etc. So my constant proportionality, k, for this particular scenario is 5. Let me put that in words. For every 1 second I travel, or Avi travels 5 feet. That's what they're looking for. Second one, C equals 4.8n. I don't even know what that stands for. Okay, so this is the same thing as this, right? And remember, our equation that represents a proportional relationship is in this format, right? So, sorry, not n. Let me take that n out. It should be an x, right? So it's always a constant proportionality, the unit rate times x. So in this case, what's the constant proportionality? K equals 4.8. And in an equation, it's very easy to identify that. Here, on the table, let me erase some of this stuff. What's my constant proportionality, right? So again, 1, what are you multiplying this guy by, right? What's that number here? Well, the only pair that I can use is this, 7, 10, and 28 over 15. So again, k equals y over x. So if you have a calculator, well, you don't need a calculator. Let's do this manually. So you're doing 28 over 15 divided by 7 over 10. So you can do that in your calculator, or if you did it manually. Remember, division can be written as multiplication. So 28 over 15 times the reciprocal, 10 over 7. We can simplify a few things, right? So it's actually 8 over 3. So the answer is 8 over 3, or a mixed number. So there. This is my k, my constant proportionality, my unit rate. Okay, for every one, I don't know, for every 1 second, I travel 8/3 of a mile. Okay. On the graph, where's my constant proportionality? Well, constant proportionality of my unit rate is here. Let me just take this. It shows up here as well, right? But I want to tell you that as a graph, it should be right here. And notice that 1 is not exactly 3. It's somewhere over here. Right? So that's 1, comma, and that is k, our constant proportionality. So, again, put it as a table. I have x and y. My x is 2, my y is 5.5. So how do we find a constant proportionality? Again, I'm going to take k, take 5.5, divided that by 2. And 5.5 divided by 2, 5.5 divided by 2 is 2.75. So if I have 1 over here, it would be times 2.75. So the constant proportionality, right, times 2.75 times 2.75. So there's my constant proportionality. So for 4, my k is 2.75. So I can take any point on this graph. And if I divide the x, y value by the x value, I should always get 2.75. So k is 2.75. Yeah, I know. That's it. There's not much to this question. 3. All right, 3 looks like the question we did in class. Here is a table. I'm going to translate that. X and Y. We have a point X, which is half, and when I have half of something, I get 3 of something else. That's what that says. So they're asking us, hey, does 9 and 3 over 2 follow the same ratio? Is 1 and 6 follow the same ratio? Let me continue the table here. What about 1 and 3? 3 over 2 and 1 over 4, is that the same ratio between y and x? And then the last one, 7 over 2 and 21. Well, let's look at the original one. This is the important one, right? So let's find a constant proportionality here. So k is going to be 3 divided by a half. Oops, not 1/3, a half, right? So 3 divided by a half is going to be 6. So times 6, let me change colors here, times 6. So everything should be times 6. In other words, so you either can check doing it this way, times 6, times 6, times 6, times 6, or you can take each of these pairs and divide, take that one and go 3 over 2 divided by 9, and then 6 divided by 1, right? And then here 3 divided by 1, and over here 1/4 divided by 3 over 2, and the last one 21 divided by 7 over 2. You can do it that way, or if you found the unit rate, it's times 6, right? The unit is every time there's 1 of x, there should be 6 of y. So over here we know that's true. Is 9 times 6 3 over 2? No. Is 1 times 6 6? Yes. Is 1 times 6 3? No. Is 3 over 2 times 6 1/4? Let me see. 18. No, that's also a no. It's 7 over 2 times 6 21. Yes. So the points, so if I were to graph this, the following points would be on this line. First one, this one, the given one to us. 9 and 3 over 2, 1 and 6, this one will be there, will be on the line. And what else? And then 7 over 2 and this one. All these 3 points would be on the same line. They would have the same constant proportionality. The other ones, they just don't work. 6. Here's a description of a graph in a table. Which one represents a different relationship than the other ones? Well, so they're asking, it's just how we do the problem. Does this become this, and does that become that? Or they all represent the same thing, but they're saying one of them is different than the other. Let's look at the table, because that's the easier one. How does 2 become, let's find a unit rate. So let me put a 1 over here. What if I had 1 hour? I worked 1 hour. Well, find a constant proportionality, 25. Let's pick any pair, it doesn't matter. 25 divided by 2, so k is 12.5. That means that for every hour that I work, I make $12.5. Right, so this is times 12.5, times 12.5, times 12.5, times 12.5. Okay, so we know that k for this one is 12.5. But here, Joseph has worked 12 hours and makes 180 bucks. Well, okay. He works 12 hours, makes 180 bucks. Let's see if the constant proportionality is 12.5. Well, k, 180 divided by 12. 180 divided by 12 is 15. This is times 15. So he doesn't have the same, he doesn't make the same amount I do. He makes $15 an hour, right? Because if he had 1 hour of work, he would make 15. Is that the same as this one? So Joseph, so the first one, right, 1 and 3 are different. What about 2? 2 says, I work 4 hours, I make 15 bucks. So let me create a little table over here. I work 4 hours, I make 60 bucks. What's my constant proportionality? Well, if I do 60 divided by 4, right, I get 15. So this person here makes the same as Joseph. Every hour he makes 15. So 1 and 2 are the same. This and this. But 3, whoever works for that company, they make $12.50. They make a little bit less. Okay. 7, 8, 9. Here's we have an equation. C equals 2.95 grams. Gives the cost of gas, so this represents the total, the cost. This is, G represents the gallons, right? So let's identify our parts. And 295 is the price per gallon. Okay, so once you understand that, you're okay. And again, 295 is your K, is your also your unit rate, right? So 295 is a lot of things. So they're asking for us for 4 ordered pairs. What does that mean? Well, if we created a graph here, right? So I know that with 1 gallon of gas, and this is my gallons, and this is my, I'm going to pay 295, right? So there's my point, 1, 295. And then if I created a line, can you give me other relationships on this line? What if I had 2 gallons? What if I had 3.5 gallons? What if I had 10 gallons? Can you give me other order pairs? That's what the question is asking you. So the easiest way to do that is to just create a table. They didn't tell us, give us numbers of gallons. We can just make it up. Look, 1 gallon, 295. 2, 3, 4, and I'll even do an extra one. Right? So 2 gallons, 2.95 times 2, I would pay $5.90. 3 gallons, I would pay $8.85. 4 gallons, I would pay $11.80. 5 gallons, I would pay $14.75. So they asked her for 4 different pairs. There you go. So you can write 1, 295. That's a pair on my line right here. Another one, 2, 5.9. 3, 8.85, and then 4, 4 comes with $11.80. What does 295 represent? I already did that in the beginning. It's the price per gallon. You can get about 1/3 of a gallon of gas for $1 per dollar. So what if I had, let me go the other way. So this represents the gallons, and this represents the dollars. What if I had $1 only? And I said, I get to the station. I've done that. You get to the station with $1 because I had no money, right? I had $1. How much can I get in gallons? Can I get a full gallon? I can't. So can you get about 1/3? Well, what was the constant proportionality? We multiply everything by 2.95, right? So going the other way, we divide by 2.95. So 1 divided by 2.95 gives me 0.33 gallons. So is her statement correct? Yes, it is. For $1, you can get about 1/3 of a gallon in gas. Okay? And that's that.